I do want to mention one thing before we start on this lab. I misspoke, and I misspoke horribly at the end of the last video. I'm so used to saying, okay, now I'm going to get rid of everything we did here and erase the configs, and we'll do something else in the next lab. That is not the case here. I did not erase the configs. We're actually continuing that lab and adding a routed port, or a layer 3 port. We're going to put an IP address on a routed port the same way we do any other interface. But routed ports are actually our physical switch ports. Our SVIs, of course, as we've seen in action, are logical interfaces. Now I'm going to add this router, and the fast Ethernet 0/0 interface is the one that's connecting the router to the switch. And on the router, the address is going to be 210.111/24. We'll stick with 11 as the last octet on the multi-layer switch and go with 210.111 there on 0/5. Before we do that, though, we have to make this a routed port. We have to make it a layer 3 port because by default, most Cisco switch models, not all of them, but most of them are running all the ports at layer 2 by default. So we need to change that, and the command is actually a negative one. It's no switch port. And you should wait for a couple of messages. You're going to get one about the port itself, and then about VLAN 1. It's going to say the line protocols just went down. Then it's going to tell you everything just came right back up. So everything is beautiful right now. But again, that all takes place in what, about 3 seconds? Yeah, it takes place in about 3 seconds. So that's fine. Now we can go ahead and put our IP address on there. And we don't have to open it because, as we know, it's a horrible default. But switch ports are open by default. That's also a security issue we have to be careful about. So let's go ahead and do a show interface fast 0/5. And we can see the interface is up. Hardware is fast Ethernet. There's the MAC address and the internet address 210.111/24. Another one I want to show you as far as the show commands go is show interface switch port. Now, the reason I just put that command in is if you put show interface switch port in and hit enter, it's going to give you information about every single port on the switch, and that's probably not what you wanted. I think you have to do it. Yeah, but show interface fast 0/5 switch port. There you go. And that will just tell you point blank, you know, whether it's disabled or enabled as far as a switch port. Now, the thing is, you look at that and you might think, okay, the port is disabled, but it's not. It's the layer 2 capability of the port that's been disabled. It could be put a better way. I would be the first to say that. I would just say, this port's running at layer 3. But they didn't ask me. They just did it this way. So when you see switch port disabled under show interface fast whatever switch port, if it says disabled, that means it's running at layer 3. That's actually what we want right now. So stepping back to our map for just a moment, first we're going to try some pingability right now between the switch and the router itself. And we'll go ahead and ping 210.111. And that goes right through. We lost our first packet, that's fine. And then after that, they're cooking. So everything's rocking right now. What about our hosts, though? Let's go out to host 1 and try to ping 210.111, which is our router. And let's see, it looks like it's not going to go through, but let's see what kind of results we get. And it looks like we're just getting 5 timeouts. What's the best thing to do if A can't ping B? And in this situation, you know, we don't really know where the problem is. Let's say you came in on the middle of this and it's just like, okay, we got this problem, you got to fix it. Okay, so it's not enough to know where you don't have connectivity. You need to know where you do have connectivity. That's a great troubleshooting motto to live by. And what I would do in this situation, what I am going to do, is from host 1 ping fast Ethernet 0/5 on the switch. You know, do I have connectivity there? And that's 210.111. And I do have connectivity there. Now, am I going to have the same result on 3? Let's try pinging first the router 210.111. We're not going to get anything there. We pretty much knew that. So what's my escape sequence there? Control-Shift-6, Control-Shift-6. And let's try 11. Okay, see, this really tends to separate network admins from network admins because you've already localized where the problem is. You know, as I don't say it disparagingly, but I do say anybody can send a ping. Okay, it's knowing where to ping and starting to narrow down where the problem is. And right here, we don't have any problem between the host and the multi-layer switch. We know we could ping the default gateway. We did that in the previous video, but now we're able to ping fast Ethernet 0/5 from both host 1 and host 3. But our pings to the router die. And there's something about ping here that I just really want to remind you of. I know you know this, but I'm going to remind you anyway. It's not enough for packets to get from A to B. They got to know how to get from B to A. They got to know how to get back. And right now, the router doesn't know how to send them back. It doesn't have any idea. It doesn't have anything right now. So what we need to do is get a routing protocol set up between our multi-layer switch and our router. And that's exactly what we're going to do. We're going to configure EIGRP on both. So let's go up to, I renumbered this. Hooray, got it. And just do a quick router EIGRP 100. And we're on the router, so the only statement we need is this one. Right? That's it. Now down on the switch, we're going to need a couple of statements there. First, we'll need this one. See how fast our adjacency, yeah. And we get a message saying dual. Of course, we know what dual is. Neighbor change, EIGRP IP version 4 AS100. The neighbor is up, new adjacency. You ain't just kidding. So let's go ahead and do put our two other networks in. Almost got me. I know that we have that neighbor, but I look at it anyway because I can't help myself. And it's been up for about 31 seconds now. Everything looks good there. Let's go up to the router. And you can see that the router now has a couple of entries. I did show IP route EIGRP to see only the EIGRP entries. And it's got an entry for 2110 and 3110. Everything looks good there. So while we're here, let's try to ping our hosts and see if they come back. And there you go. And a moment ago, our host could not ping 210.111. There you go. And we'll go over to 3. And that's all there is to it. So with this lab, I should say, the thing was we needed to remember first off to make that port a non-switch port. We saw how to verify that. And then you just set up a routing protocol just like you would on a router to exchange some routes. And we were all set. We did these verifications. And we know now that everybody can ping everybody else. The adjacency came up fine. Just, you know, everything is just as you would expect to see it on a router. Don't let, oh man, I'm on the multi-layer switch, you know, intimidate you in any way. It is just like configuring a router in many, many ways. Now, that takes care of our routed port, and we've seen an SVI in action. I'm going to create a bonus video next that's just going to list some troubleshooting tips and things for you to look for with each particular one of those, and then we'll move forward into the high availability protocols. I'll see you on the next video of those tips, and then we'll do some more labs.